bipolar junction transistor. So we have completed few questions. Let us continue with the next question. This particular, that is, we were discussing the configurations of the transistor and how the static characteristics will differ in functions. So continuing that, one of the questions you might expect is discuss the output characteristics of transistor. So in the common emitter configuration, what is the things you can able to? So here we have sticks with drawn respect to IC versus CV keeping IP state. So if we do so by keeping the IP constant value, varying the C corresponding IC, we are going to back on, and after that that is IC versus DC. Here it will be divided into the output characteristics from three regions: saturation region, active region, and what is the saturation region, active region of region is? In this saturation region, so in this saturation region, one by one we will discuss. So first is saturation region. Here what happens? The VCE is increased above 0, and collector current increases with the saturation depending on the value of current is current I. Then IC reaches saturation value when the VCC is greater than, is greater than. So here in the saturation region, what happens? The base emitter junction is forward biased, and your collector base junction is also forward biased. So the transistor acts as switch. This saturation, this is going to. So this is saturation. Next, discuss active region. So what happens in active region? So what is going to happen? Active region is here the junction is forward biased. Then collector base junction will be reverse biased. And transistor acts as an the application transistor which is active this particular active region. So here what is happening? The IC will that DC times gain times gain then greater than this time. Thus small input produces large. So there is a small change or small change in this input current which is going to a large change in the, hence this region transistor acts as a, so this is the gain factor. This much has been amplified this many times and it is going to be, so it acts as an amplifier, this active region. In the cutoff region, what happens? The PE as well as CB and it acts as a switch, that is the off. Because IB is 0, IC is 0, small collector current exists. That is nothing but the reverse leakage. So due to this, there will be some reverse leakage current due to the charge cables. So it is almost off this off. So this is what you have to explain output resistance. And one more we can tell, that is punch through effect or base width effect or this early slope of the characteristic. So this early, what is this early effect? When the reverse bias voltage VCB in the CB junction exceeds the maximum specified by the manufacturer, then CB depletion region will penetrate CB depletion region penetrates deep until it becomes to contact the base interdepletion region. So this is called as punch through effect or early effect or early. Remember, this VCB exceeds maximum value given by the or specified by the manufacturer. The CB depletion region penetrates deep into the base such that E depletion region comes in contact with the CB depletion region. This will be given as punch through. This leads to breakdown of the device and very large current in the device. So excessive flow of current can damage the transistor. So the maximum value of this VCB will be reaching from 25 volts to. So these are a few things which you have to explain in the characteristics of transistor. Then next question is, explain the concept of transistor biasing and its necessary for the proper operation of transistor electronic circuits. So what is this biasing? This biasing is a process of energizing the transistor to amplify AC signals such that fluctuations in AC signals should not drive transistor to the cutoff or saturation region. This we name it as biasing. We always make sure that the transistor operates in active region. Then only you can able to amplify the signals. So for that, we are giving some energizing the transistors through giving voltage that we need as transistor signal. It is nothing but, in simple we can say, to set up a Q point of the transistor of the DC load. So, what is this DC load line and Q point expression? For that, in the transistor amplifier circuit, the biasing can be done to power supplies, that is BJT, CC. So there are some different biasing circuits. Base bias circuit, base bias with feedback or corrective bias, HDI. So these are the three different biasing circuits which are going to study. Now you understood what is transistor biasing, what are the different circuits from this transistor biasing circuits. Now why this biasing is necessary for proper operation of transistor? This the main two reasons. To keep base emission if you do this, then only transistor will be in active. So to make that, we make sure that this B junction and CB junction, B junction is power bias and CB junction is reverse bias. This is one of the necessity why we transistor bias. Next, to stabilize the EQ point or quiescent point against the changes in temperature, variations in transistor parameters, aging of the, so all these matters we are designing some the amplifier circuits using transistors. So the Q point, whatever you are choosing, that should be stabilized against all these changes. These external factors, that is changes in temperature, variations in transistor parameters, aging. So to stabilize the Q point and to keep these junctions forward and reverse biased, we need this transistor biasing. That is, if we are make sure that B and CB junctions forward biased and reverse biased, this will ensure the linear operation of the transistor and flow of proper collector current, the BB, proper of the C. So if we make this forward bias and this forward reverse biased, then we are ensuring the function of transistors. So there will be proper flow of the transistor parameters IC, EB. Then if we are making sure to stabilize the Q point, then that stabilizing Q point is necessary to protect the transistor from. So in short, we can tell biasing is essential because it sets the transistor's working point, enables linear amplification, ensures stability and. So for these things, we need